Hi friends, today we are discussing about angular velocity of a particle. Particle in two dimensions. The angular velocity of a particle is measured around or relative to a point called the origin. As shown in the diagram with angles phi and theta in radians. If a line is drawn from the origin O to the particle P, then the velocity v of the particle has a component along the radius component v, and a component perpendicular to the radius cross-radial component v lambda. If there is no radial component, then the particle moves in a circle. On the other hand, if there is no cross-radial component, then the particle moves along a straight line from the origin. A radial motion produces no change in the direction of the particle relative to the origin. So for purposes of finding the angular velocity, the radial component can be ignored. Therefore, the rotation is completely produced by the perpendicular motion around the origin, and the angular velocity is completely determined by this component. These, the, these are the equations which we are discussing about it. In two dimensions, the angular velocity omega is given by omega is equal to d phi by dt. This is related to the cross radial velocity by v lambda is equal to r d phi by dt. An explicit formula for v lambda in terms of v and theta is v lambda is equal to v into sine theta. Combining the above equations gives a formula for omega. Therefore, omega is equal to v sine theta by r. In two dimensions, the angular velocity is a single number with an orientation but no direction. The angular velocity in two dimensions is a pseudo scalar, a quantity that changes its sign under a parity inversion. The positive direction of rotation is taken by convention to be in the direction towards the y-axis from the x-axis. If the parity is inverted but the orientation of the rotation is not, then the sign of the angular velocity changes. There are three types of angular velocity involved in the movement on an ellipse corresponding to the three anomalies: true, eccentric, and mean. This is the information about angular velocity of a particle. Thank you for watching.